All right, so we're going to talk about rationalizing complex numbers, which is essentially just dividing complex numbers. So you might be asked to take an expression like this one and simplify it. Basically, you've got a complex number on the top, complex number on the bottom. Really, the only issue with fractions of complex numbers is we don't really like to have a complex number on the bottom. We just like to have, as a general rule, we like to write our complex numbers like this: a plus bi. We don't want it to be a plus bi over c plus di, right? We want to be able to write it, to simplify it, so that it's just some number, some real number, plus some imaginary part. Okay, so in order to do this, what we're going to do is we are going to multiply by the conjugate of the bottom part. So we're going to multiply by the conjugate of the bottom part, which I'm going to call the denominator, because that's its name. And the conjugate, so we should probably talk about what a conjugate is. If a plus bi is a complex number, I'm going to move down here a little bit. Its conjugate is a minus bi. So literally all we're going to do is, and this is really important that you get this right, you're going to change the symbol, the sign in front of the imaginary part. So you change the sign that goes with the imaginary part. If you goof this up, it will mess up your problem. Well, we're going to look at a problem later where that happens, okay? So like where it's really important that you get it just right. Okay? So if you had 2 plus 3i, the conjugate would be 2 minus 3i. Okay? All right. So what we're going to do is we're going to multiply the top and bottom of this fraction by the conjugate of the bottom. So the bottom is 5 plus 4i, which means we're going to multiply the bottom by 5 minus 4i. Since we do it to the bottom and we don't want to actually change this number, we're going to multiply the top by the exact same thing. And so what's going to happen here is we're going to have to distribute this. So when we do this, and this is going to be a little hard to track with visually, but if you do those two first, then you multiply the green two, and then this is where it's going to get a little tricky to see. We're going to multiply those two, and then we're going to multiply 3i by negative 4i. So what would happen here? On the top, we're going to get 2 times 10 in the red there. Sorry, 2 times 5, that's 10. In the green, we're going to get 2 times negative 4i, so that's negative 8i. For the yellow, we're going to have 3i times 5, so that's 15i. And for the blue, we're going to have 3i times negative 4i, so that's going to be minus 12i squared. That's the top part of this fraction. The bottom part, we're going to do a very similar thing. We're going to multiply the first two, and then the outer two, and then we'll multiply the inside terms, and then we'll multiply the last two terms. So it gets a little tricky with the color coding, but 5 times 5 is going to be 25 for the red there. Plus, what's the green going to be? So if we do 5 times negative 4i, that's negative 20i. When we do the yellow, we have 4i times 5, so that's plus 20i. And then for the blue, on the bottom, we'll have 4i times negative 4i. That's going to be negative 16i squared. Now let's simplify. So on the top's going to be 10. If you have negative 8i plus 15i, then you've got 7i. And then you got minus 12i squared. On the bottom, we've got 25. And this is really convenient. We've got negative 20i and positive 20i. And this is how, by the way, this is how we're able to rationalize the denominator. Rationalize just means that we make it so that what we have is one complex number, not a fraction of two complex numbers. Okay? So when you multiply by the conjugate is set up specifically for this idea of getting these middle two terms, the green and yellow term here, to cancel. So when you do 5 times negative 4i, and then you do 4i times positive 5, those always cancel. And so what happens here is we're left with 25 minus 16i squared. So we just bring down the negative 16i squared there. And so on the bottom, I know there are still i's on the bottom, but they're actually going to go away because remember, I squared is negative 1. So what do we have really? We have 10 plus 7i minus 12i squared, where I squared is negative 1. That's 12 times negative 1, by the way, not 12 minus 1. And then on the bottom, we have 25 minus 16 times negative 1, because I squared is negative 1. And so from here, what do we have? We have 10 plus 7i plus 12 over 25 plus 16. So this is going to be 22 plus 7i over 41, which doesn't look like a complex number, but think about it for a second. If you write these separately, so you can divide each part separately, you would get 22 over 41 plus 7 over 41i. And that right there is totally a complex number. It's got a real part. It's a fraction, but it's still a real number. And then it's got a real number times I. So it's got the imaginary part right there. So that would be the solution. Well, not the solution, but that would be the simplified form of the original fraction. All right, so let's look through another example here. So we've got 2 plus 2i over 3 minus 4i. And the idea here is that we're going to multiply by the conjugate of the bottom. So the conjugate of the bottom is going to be 3 plus 4i. So we're just changing the sign that goes in front of the imaginary number. So 3 plus 4i. Since we do it on the bottom, we have to do it on the top because we don't want to actually change this number. And if you multiply a number by the same thing on the top and the bottom, you're not actually really changing the number. You're just rewriting the number in a different form. All right, so I'm going to distribute on the top here, and I'm not going to color code it all pretty. So what I'm going to do is I'm just going to write these out. So 2 times 3 is 6. 2 times 4i is 8i. 2i times 3 is 6i. And 2i times 4i is plus 8i squared. That's the top. The bottom becomes 9. 3 times 3 is 9. 3 times 4i is 12i. Negative 4i times 3 is minus 12i. And then negative 4i times 4i is minus 16i squared. So we're just going to simplify here. So on the top, we'll have 6 plus 14i. And how about in the same step, we put plus 8 times, and then instead of writing I, we'll put negative 1 there. Okay? All right. So we got that. And on the bottom, we've got 9 plus 12i minus 12i. So those are going to cancel each other out. And then we've got minus 16i squared. Instead of I squared, I'm going to put negative 1 there. All right. So we got 6 plus 14i minus 8 over 9 plus 16. which is negative 2 plus 14i over 9 plus 16 is 25. I'm going to move a little bit here. So if we rewrite this and we divide each part by 25, we're not really dividing by 25, but we're just rewriting it. So negative 2 over 25 plus 14 over 25i. That would be your final solution here for this one. All right, let's look at another one. Okay, simplify 5 plus 3i over 3 minus 5i. So we're going to multiply by the conjugate of the bottom. I'm just going to put parentheses around everything. Conjugate of the bottom is going to be 3 plus 5i, because all we're doing is changing the sign of the bottom, imaginary number on the bottom. And when we multiply this out, let's do the top here. So 5 times 3 is 15. 5 times 5 is plus 25i. 3i times 3 is 9i. And then 3i times 5i is 15i squared. On the bottom, we'll get 9 plus 15i minus 15i minus 25i squared. So what is this really? This is going to be 15 plus 34i plus 15 times negative 1. So I collected the 25i and the 9i, and then I just turned the I squared into negative 1. And on the bottom, we've got 9 plus 15i minus 15i, so those go away. And we're just left with minus 25i squared. Instead of I squared, I'm going to put negative 1, because that's what I squared is. Okay. From here, we've got 15 plus 34i minus 15 over 9 plus 25. So what do we really have? We have, on the top, those 15s actually go away, so we just have 34i over 34. Whoa, that's kind of interesting. So when you simplify this down, you actually just get I, which is kind of interesting to say that I is actually equivalent to 5 plus 3i over 3 minus 5a. That's interesting. Which means, oh, this is even more interesting. If you squared this, theoretically the answer would be negative 1, right? Because we know that I squared is negative 1. And if this is equal to I, then we have negative 1. So anyway, it's kind of interesting. All right, let's do one more example. All right, so we've got 2i plus 3 over 3i plus 4. And these are kind of weird because they're not written in typical complex number form. Usually we put the real number first and then the imaginary part second. But this is fine. So, all right. Here's where people make mistakes a lot. Okay? We're going to multiply here by something, but a lot of people screw this up. We're going to multiply by the conjugate. The conjugate is where you change the sign in front of the imaginary number. Many people are tempted to write 3i minus 4, but don't do that. You want negative 3i plus 4 because you need to change the sign in front of the imaginary part. So negative 3i plus 4. Okay? Another way you can think about this is if you really want to write the bottom as 4 plus 3i, this is the exact same thing. If you want to write the top as 3 plus 2i, that's fine. You could do that. And think about this. This is super easy. What would the conjugate be? It'd be 4 minus 3i, which is exactly what we're saying up here. Negative 3i plus 4 and 4 minus 3i are the same thing. So if you want to rewrite these and put the real number first and the imaginary number second, that's totally fine. That might make it easier for you. All right. Anyway, what do we get on the top here when we multiply these out? So we're going to get negative 6i squared. So that's 2i times negative 3i. When I do 2i times 4, I'm going to get 8i. When I do 3 times negative 3i, I'm going to get minus 9i squared. Just kidding. Just I. And then 3 times 4 is 12, so plus 12. On the bottom, we'll get negative 9i squared plus 12i minus 12i, and then plus 16. By the way, if you ever try to rationalize a complex fraction and you don't get these i's to cancel on the bottom, you probably messed up. You done messed up, Ron. All right, negative 6 times I squared, which is negative 1. Okay, if we have 8i minus 9i, that's really minus 1i. I'm just going to put minus i, and then plus 12. And then this will be negative 9 times I squared, which is negative 1. The plus 12i and the minus 12i cancel each other, and we're just left with plus 16. So we're just simplifying at this point. So we got 6 minus I plus 12 over 9 plus 16. So what is this? This is 18. I'll scroll down a little bit here. This is 18 minus I over 25, which is really just 18 over 25 minus 1 over 25i. So that would be your final answer for this one.